Thank you. This is a follow-up to my talk I did last year on infinity and space. Okay. Last year I was going to say we're talking about infinity, but I've only got 25 minutes to talk about it. Tonight I'm talking about nothing, but I'm going to say something. The contents of my talk. First of all, nothing. Can we define it? What is it? Secondly, was there anything before the Big Bang? Thirdly, what was the universe expanding into? 4 parallel universes, could they exist? The only reason I put Shakespeare on, I'm going to talk about cosmology, but I put him on because the line out of King Lear, very famous, nothing can come of nothing, speak again. And the reason I put that on is because that wasn't original to Shakespeare. It actually goes way back to the ancient Greeks. And I've only taken this example, Parmenides, who said, being alone is, and nothing is altogether not. So for many people, for many centuries, something and nothing were polar opposites. If you had something, you had nothing. If you had nothing, you didn't have something. And modern cosmology, could say, has muddied the waters, and it's not quite as clear whether it's as simple as that. I've used these 2 books on the left. Frank Close, whose book on eclipses I reviewed last year, his book on nothing, a very short introduction, a very good book. I do recommend it. And then I thought I was going to use this one, A Universe from Nothing, came out exactly 10 years ago by an American physicist called Lawrence M. Krauss. Why there is something rather than nothing. And I will tell you at the end a very good reason why I have not used that book very much. I've used lots of other things instead. I thought you'd just like the quote from Douglas Adams, The Hitchhiker's Guide to the Galaxy. For a moment, nothing happened. Then after a second or so, nothing continued to happen. I thought you'd like this drawing of the Big Bang. I can't remember which university produced it. The universe before the Big Bang, actual size. I think they've got the shape of the Big Bang wrong, but never mind. So most cosmologists nowadays, of course, accept the Big Bang. But did anything predate the Big Bang? One of my very early talks was on that. Some physicists think something can predate the Big Bang. And the standard view, classically going back to St. Augustine and beyond him, was that time and space only came into existence at the Big Bang. So logically, there is nothing before the first second. I thought you might like this painting about it. Jim Holt, if you ever get a chance, watch his YouTube lecture. It's a very good lecture on cosmology, and there's no less a person than Lord Rees sitting in the audience on the front row, and he tells the story of Jim Holt, that when he studied philosophy, which is what he studied first, he asked his old philosophy professor at university, why is there something rather than nothing? And his philosophy professor said, oh Jim, even if there was nothing, you still wouldn't be satisfied. Mathematician Ian Stewart says nothing is more interesting than nothing, nothing is more puzzling than nothing, and nothing is more important than nothing. Nothing is, well, nothing, a void, total absence of thingness, which sounds straightforward, but in fact, if you read some current books on cosmology, you'll find it isn't. Frank Close said that he came to a stage in his life where he started to wonder, what if there were no life, no Earth, no planets, sun or stars, or atoms with the potential to be reorganized into future somethings? What if there were just emptiness? I tried to imagine the nothing that remained, and it's very hard to think about the void. It is. You might, when you've had about 4 or 5 pints, be able to see things a bit more clearly. The only trouble if you do that is you won't remember the answer that you've come up with when you wake up the next morning. He also came out with this statement. Can't see it. I've actually got something in the way, Steve. Can I get rid of those things at the top with the things, the signs on them? Can't get rid of them. I can't get rid of them. Right. Yeah, wait a minute. Get rid of them. No, get rid. Oh, here we are. Right. Does space exist independent of things in the sense that it would remain forever, even if you took all pieces of matter away? Yeah. Or would the remainder of space, sorry, I can't read it, I'm afraid. Got a thing in the way. Right. Steve, are you there? I can't move, and I can't get rid of that thing at the top of the screen.
Right, is it the thing with the transcripts?
Yes.
About transcript?
Yes.
There's a little X towards the right hand side.
Thank you very much.
Click on that, yeah?
Thank you. Lovely.
Sorry, I did tell you that before, but I was still on mute myself.
Sorry, I do apologise. Let's start again. So he says, does space exist independent of things, in the sense that space would remain forever, even if you took all pieces of matter away, or would the removal of matter do away with space as well? Well, if you go back to Aristotle, Aristotle said if you take all things away, you're left with nothing. And he said, nothing can't exist. He said, nature abhors the vacuum. When you get to Sir Isaac Newton believed that space and time existed independently from anything in space. They existed in their own right. And just to complicate things, Einstein, of course, said that space and time were intimately connected, and that if you do something in one of those dimensions, it'll affect what happens in the other dimension as well. So things have got slightly more complicated. My only bit of astronomy, which I was actually going to use, was this picture of the Boutet's void, which makes a great claim here. It's the great void in Boutet's, a huge void in space where there's nothing for 250 million light years. That's actually, that's actually wrong on two counts. One, because empty space is not empty, there is something in space, so you can't say it's completely empty. But also some galaxies have been discovered in that space, but there's not as many galaxies as perhaps there are in other areas of space. So what is nothing? Well, as it says there, it takes a long time to understand nothing. And as Frank Close says in his book, the answer depends on what you mean by nothing. So you could say the answer to the first question is, we don't fully know, although different people have different ideas. Okay. Arno Penzias, who's one of the co-discoverers of microwave background radiation, said astronomy leads us to a unique event, a universe which was created out of nothing. Okay. So what actually, oh, don't say it's doing it again. Oh dear, I'm sorry. Right, what actually happened? Well, there are various theories. The first one, which I'm not advocating because it's first, but I'm just saying the idea that a God created the universe, and that's normally given the Latin phrase creatio ex nihilo, created out of nothing. The second option is that either one God or several gods created the universe, but they did it from material that was already there. The third option is that it came from nothing at the Big Bang. The fourth option is that we are one of several universes, and I'm going to say something in detail about that at the end of my talk. And of course, the final option is it's always existed, which is what Aristotle believed, and the steady state theorists, Fred Hoyle, etc., that's what they believed. Okay, I thought it was time for a cartoon after all the playing around that I've done, so I thought you might like that. Stephen Hawking said, one can't prove that God doesn't exist, but science makes God unnecessary. The laws of physics can explain the universe without the need for a creator. It's that last sentence I want you to focus on. The laws of physics can explain the universe without the need for a creator. So we might say, where do the laws of physics come from? There are 5 options. They come from God, if God is the creator and he's the lawmaker. He set the universe in existence with the laws of physics already in place in the universe. Second, they just exist as brute facts. They're just there. You don't need an explanation for why they're there. But they are, number 3, they're there because of logical necessity. They have to be there to explain the phenomena that we're confronted with. The fourth option, there are different universes with different laws. Our universe happens to be fortunate enough to have the laws that allow life and reflective beings to emerge. And Luke Barnes, who's an astrophysicist who favours the idea that we are unique, actually, but he says, he's written a book called A Fortunate Universe. We happen to live in a universe where we can be here doing the thinking, talking, meeting and observing. And the fifth one, the laws of physics are merely human attempts, human inventions designed to make sense of the universe we believe in. The two that are actual, you can't contest, are 2 and 3. the laws of physics are there, and they must be there from a logical necessity. 1, 4, and possibly 5 are matters of belief, whether you believe in other universes and whatever, and whether you believe in God or not. But Mikio Kaku, who's a Japanese-American physicist, says, no one knows who wrote the laws of physics or where they come from. Science is based on testable, reproducible evidence, and so far we cannot test the universe before the Big Bang. And I put the question there because of what Stephen Hawking said, because it implies what he said, and I've got another quote from him, that the universe exists because of the laws of physics, which seem to imply, and some people have criticized him for saying it, it implies that the laws of physics cause the universe to exist. But logically, if the laws of physics didn't exist before the universe existed, because nothing existed if this universe is unique before the Big Bang, it's difficult to see how the laws of physics can explain in the sense of, does it cause the universe that we live in to exist? Leave you with a question there. Thought you'd like another cartoon, by the way. I thought you'd like that one. Okay. Frank Close says, if the universe can be seen as on a vertical line, there was no time before time. Indeed, there was nothing before time. And he says, this is where the concept of the void has flourished, where poetry fills the vacuum of our incomprehension at the limits of imagination. All diagrams showing the evolution of the universe, that's mine that I've used. The one that our last formal speaker used, which I used in a previous talk of mine, seems to make it look as though the universe exists inside something else. But the universe can't be inside something else, because the universe is everything by definition, if this universe, and I keep saying this, is unique. All right, so what about the question, what is the universe expanding into? Just bear with me for a second on this. The universe can't expand into something that isn't there. If the universe comprises all that there is and contains all matter, energy, space, and time, there is nothing else, which means the universe is just expanding, that's all. You can't really say it's expanding into something, because by definition, what is outside the universe is not something, it's nothing. But you have to qualify that, because there's people who believe that there have been universes before this one in a whole series, a bit like waiting for Arriva buses, or there are parallel universes, there are other universes. I thought you'd like this quote from Albert Einstein. It says, once you can accept the universe as matter expanding into nothing, at least that's something. And compared to that, wearing stripes with plaid comes quite easy. Okay, let's look at parallel universes, okay? They're also called alternate universes or multiverses, and I found out today that's slightly inaccurate. Multiverses refers to the plurality of possible universes, but alternate universes is a synonym for parallel universes. They are theoretically possible, and a few years ago this idea was floating around about wormholes, a sort of two-ended black hole, sometimes called Einstein-Rosen bridges, which could link 2 points in space-time, even different universes. Even, it's been suggested, that one will emerge, a new universe will emerge when you get to the end of the wormhole. I looked at 2 different astronomy dictionaries today, and one said, oh, there's not much evidence for that, and the other one said it's an interesting idea, so you can take your pick. One thing that you can't do, you can't test empirically whether there's more than one universe. And as somebody said, an astrophysicist called Luke Barnes says, the hypothesis that a multiverse actually exists will always be untestable. I was actually reading a book today all about it, which I'll mention at the end, published by New Scientist magazine. And there are crazy people, including 1 or 2 scientists and philosophers. You can understand the philosophers, but not the scientists, who actually live their life on the basis of making decisions on the basis that there's another them in another universe taking the same decision. And I thought there's some crazy people around, but I don't expect to find them in the scientific community. The jury is divided. When I looked this up on the internet, there's almost equally balanced eminent physicists thinking there could be parallel universes against those who don't think there are parallel universes. Lord Rees is sympathetic to the idea there are parallel universes. Stephen Hawking apparently was. Paul Davies, who wrote the book God and the New Physics, he's one that's against. And I've also put +1 against. I'm not putting myself in the category of an eminent scientist, but I'm very skeptical of the idea. Why is this picture misleading? It's misleading because it's assuming, again, as diagrams of the history of our universe do, that there is something happening between the universes. If the universes are self-contained, there can't be anything between them. In a sense, you can't actually draw them. They'll all be end to end, if you like, if you can see it that way. Lawrence Krauss's book, I'll tell you in a minute why I've not used it in this talk. I've nearly finished the talk. He comes out with a statement, if you've nothing in quantum mechanics, you'll always have something. And I think there's proof there, because if you look at this picture of him on the left-hand side, there's nothing, he hasn't got a beard. And on the right-hand side, he has got a beard, so it's something coming from nothing. He says that quantum mechanics can explain the existence of the universe, because in a quantum physics, quantum mechanics allows for the spontaneous eruption, if that's the wrong word, I hope it isn't, of particles. Therefore, the universe can come from nothing. But of course, I would take issue with that. Somebody might take issue with me at the end. Quantum states when we've got a universe is one thing. Talking about quantum states when we haven't got anything at all, to me, is purely hypothetical. But the reason that I haven't quoted from his book, can you all see the next slide?
Yeah.
Yes.
Yeah. Is because sentence 1 of this book, which is supposedly all about science, says, I must admit that I'm not sympathetic to the conviction that creation requires a creator. The last sentence in this book is about whether God exists or not. And Richard Dawkins went on record as saying about this book, which came out 10 years ago, if the book on the origin of species was biology's deadliest blow to supernaturalism, we may come to see a universe from nothing as the equivalent from cosmology. And I was a bit disappointed, because I thought when I read this book and reading all the people are saying it was a great book, it was going to tell me something about science. No, about a quarter of it's about theology. I don't want to read theology in a science book. And of course, Richard Dawkins and Lawrence Krauss are big pals. There's a picture of them together. I hope you can see that. I actually feel as though, well, if you listen to Lawrence Krauss's lecture on YouTube, you'll see what I mean. He keeps having a go at religion every 5 minutes. And I'm thinking, I don't want this. I want science, 100% science, not having a go at religion as if that's part of their mission, which of course Richard Dawkins, I'm afraid to say, thinks it is. So to bring it to a conclusion, can you see that one all right? Yeah.
Yeah.
Frank Close says at the end of his book, he's an atheist as well, but he's a bit more open-minded. He says everything that exists, it may thus be a quantum fluctuation out of nothing. But if this is so, I'm still confronted with the enigma of what encoded the quantum possibility into the void. As science discovers answers, it exposes deeper questions. And he finishes his book with this quote from the Hindu scriptures, the Rig Veda. He says, before the universe existed, the non-existent was not, the existence was not, the existent was not, darkness was hidden by darkness, that which became was enveloped by the void. And I think if you've got that in your head, I think we've got a problem that even Sherlock Holmes would have had difficulty with. And because one of my last talks before Christmas was about C.S. Lewis, just to give us all a bit of positivity and a bit of hope, I've put a quotation from C.S. Lewis in one of his children's books. He says, into the void of silence, into the empty space of nothing, the joy of life is unfurled. And at that point, I'll say thank you. Sorry about the technical problems in the talk. I'll be quite happy to take any questions or comments when I've finished. Okay, thank you.
Right. Can we just have a round of applause there? battle on your hands there, David.
Thank you. How much can I get out of this now? Stop press
Stop sharing.
Stop sharing. I've got to stop video. Is that the same thing? No.
No, it's just
stop sharing. Yep, there we are.
Yeah.
Thank you.
Well done, Dave.
Yeah.
Sorry
Yeah,
about
good effort, David. Good effort.
Sorry about all those problems.
Well,
Right.
it's a learning experience.
Yeah. If anybody, by the way, that book I mentioned, The Universe Next Door, that's published by New Scientists. And I would say about a third of that is philosophy and history. What if the English Civil War hadn't happened? What if Newton hadn't had an apple dropping from a tree? And I thought, I repeat what I said, I study theology and I study history, but I don't want it in a science book. I want science in a science book, not somebody trying to convince me of some whether God exists or God doesn't exist. I'm sorry, I didn't read the book for that. I read it for finding out about nothing.
David, can I pitch you a question there? It was just interesting. The professor who's coming to the club in a couple of weeks is specifically talking about dark energy. I just made a note on my pad here that I keep on the computer to try and look for the difference between dark energy and dark matter. But when I was having a quick look at dark energy earlier on today, because I've been reading Jim Al-Khalili's book, The World According to Physics, it does suggest that the inflation of our universe is driven by this dark energy, which is kind of hypothesized to fill in a few of the kind of gaps in cosmology. But what was really interesting was this idea of where does our universe come from? And one of the interesting things that Jim Al-Khalili talks about is the idea that we are part of a multiverse. In other words, our universe is just a bubble in the hypothetical quantum background of another much, much bigger multiverse. So this would sort of explain that what came before the Big Bang is, well, I think as somebody's already noted, that the space-time continuum is, they seem to be kind of inextricably linked. Space is related to time, time is related to space, and the kind of gravitational effects that we see when you approach black holes with space slowing down, they're all to do with gravitational effects. However, if we just emerged out of the background of another bigger universe, well, that kind of explains where we've come from. But it sort of doesn't really explain where that other bigger universe has come from. It's just kind of shifting the puzzle somewhere else.
Yeah,
it's an interesting idea.
I know. I've been reading about that today, and yes, I can see how it works. The trouble is you can't empirically test it, and since I think it's always been accepted. Even Stephen Hawking said it once, that different properties of a scientific theory, it should be elegant, it should have no extra bits hanging on, it should be simple, direct, and it should be capable of experimental verification or falsification. You can't do that with multiverse, so you can't actually empirically test it, right? And even estimates about people saying maybe one day you could. We're talking about so far into the future that it's completely impractical. You know, that's really my objection to it. I think it sounds nice. It explains a lot of things, but it also, as you've just said, and you can say the same thing, I think, about panspermia. Panspermia tries to explain where life comes from. No, it doesn't. It says it might have arrived here via, comet or whatever it is, but it doesn't explain where life comes from. Now, at the end of the day, Frank Close, who is an atheist, he's prepared to accept there are certain things you cannot ultimately know. That's what I was trying to say at the end of my talk. I think there are certain things you have to leave as question marks and say perhaps we'll never know the answer to that question.
Yeah, it kind of ties in quite well with Karl Popper, the famous sort of scientific philosopher's idea that in order for an idea to have any kind of value or to contribute anything to science, it has to be falsifiable, because if you can't prove it wrong, how can you hope to prove it right? And it kind of ties in for me with, I read a lot of Chris Hitchens stuff, that anything that can be asserted without evidence can be dismissed without evidence. Just before I sort of go away and have a quick look online for a couple of other things that interest me, this idea, if we just I know this is an incredibly strange thing to say, but if we just focus for now on our universe, this idea is that our universe, due to whatever kind of flavor of inflation theory you subscribe to, this idea that our universe is infinite. Now, notwithstanding, I can't conceive of something that is 13.4 billion light years across. It's just too big to fit into my tiny little human head. However, this idea that I think it was Stephen Hawking put it forward, that what happens to information when it goes into a black hole? We know that the matter that it contains, say, for example, we chuck a book into a black hole, the physical book is destroyed, but the information that was encoded in that book, it has to remain. We can't destroy information. That's one of the kind of fundamental underpinning ideas, that we can't destroy things. We can only transform it into another form. So what happens to information when it falls into a black hole? And I think Hawking led on from that with his discussion of sort of Hawking radiation and some of the other sort of things that are kind of beyond my understanding as a layman. But what I think is quite interesting is that in an infinite universe, we can throw things into black holes if we so choose, but nothing, as far as we're aware, can escape a black hole. So arguably, does the event horizon of a black hole, does that equate to a boundary in the infinite? If so, then we can't argue that our universe is infinite, because it has a boundary, even though the event horizon of a black hole would form that boundary. Now, I'd be very interested to know what people think about that, because this kind of stuff keeps me awake at night.
Well, I don't know if you heard my talk I gave before Christmas. I gave a talk on, is the universe finite or infinite? And I met a university lecturer in mathematics from the University of Hull, retired lecturer, and I went up to him. He was actually playing the piano, his wife was singing, and I knew he was an ex-lecturer in mathematics. So I went up to him and I said, about infinity and finitude. And he said, it all depends what you mean by the words, when you say infinite. Because when I gave my talk, I quoted somebody who said that the universe could be infinite, or it could be finite, or it could be both. And that sounds like a contradiction. But the person who said that, who was Ian Stewart, a mathematician, he said, at the end of the day, saying that the universe is infinite and saying it's very, very big are almost saying the same thing, because we can't ever explore it. We can't ever go, that far to explore it. And the book I was reading the other day, actually, come to me in a minute, was I think it was Lawrence Krauss. Yeah, in what he says is that ultimately the edge of the universe will get so far away that if we last that long, we'll only be able to see so far. And in fact, there won't be any direct evidence that there is. We'll be back to the stage before Edwin Hubble, thinking if we've lost all historical records, that this galaxy is all we've got, because we won't be able to see as far as we can now, because of the continuing expansion. That's assuming that the universe continues to expand. So you're best actually watching Sherlock Holmes and not thinking about these things. Just put them right out of your head. Have a few beers.
That's an interesting idea, isn't it? That our universe could be simultaneously finite and infinite. Because I guess if you consider that we are an infinite universe, but with a finite amount of time, because we know that entropy tells us that things are going to break down and even out over time. So if we are an infinite amount of space, we have a finite amount of time. But if you look at it from an outsider's perspective, we could be an infinite amount of universe, an infinite amount of time, and a finite amount of universe. So arguably, we probably could be both. I guess it depends where you put your focus.
Yeah. I mean, I think at the end of the day, sorry, just the last comment. It's like some of the stuff I've been talking about. At the end of the day, it doesn't really matter what you think or believe or whatever. But I do think that a lot of the things that I've been saying, and a lot of the things about parallel universe, you're talking about what people believe. We're not really into what we might call hard experimental science anymore. We're talking about speculation. Some of the speculations might be interesting. They may possibly be true, but it's almost as if, sometimes I'm reading stuff and I'm just thinking, sorry, I dare I say Stephen Hawking sometimes. I'm not reading science anymore. I'm reading speculation, which he knows a lot more. He knew a lot more than I do. And I'm not even trained as a scientist. But at the end of the day, I think, does it make any difference? We're talking about one belief against another belief, and you can take your choice,
Can all science be verified, though, Dave?
From what, sorry?
Does it have to be a given that all science has to be verified?
No, but then what you have is, it's like with the parallel universe thing, you have people who do believe in it, scientists, and those who don't believe in it. You have people who believe there might be life out there in the universe, and those who don't believe. You have people who think this universe is the only one that there is, and those that say that there's other universes. And finally, those that say, who believe in the anthropic principle, whether you take the weak version or the strong version. If you take the weak version, it's that basically we just happen to have landed in a universe that's okay for us. The strong version is that something or someone created this universe in order that it would be okay for us. And then you're back to people's beliefs again, you know, which to me are perfectly valid. Like if you believe in God or you don't believe in God, perfectly valid. But you're not talking about science anymore, and you can't. There's Richard Dawkins claims that science can disprove God. No, he can't. It's a bit of confusion there, because he's talking about proof about something that's not really amenable to empirical evidence. Sorry, you know.
Yeah, well, it's not Popperian, is it? You can't falsify it. So
No, that's right.
I'm going to end the discussion there, if you don't mind. I dare say there's a lot of people got other questions and comments, but it sounds like perhaps we could revisit this subject at a future meeting, where there's a lot more to do yet. It's just after 8:30. I suggest we have a quick break for 10 minutes and reconvene at just after 8:40. Is that okay?
Yeah. Can I just say thank you to the 2 or 3 people who've sent me nice emails? Thank you.
Thank you, Dave. Well done for persevering.
yeah.
Thanks.
Okay.